Hello, welcome to this short video looking at 3D printing from SketchUp and some of the things you need to do to get it to work for you. Okay, so we're in SketchUp. One of the first things to realize in SketchUp relating to 3D printing is that surfaces have got two sides. They've got a white side and a grey side. Now, when making a model, it's often easy to get some of the objects white facing outwards, some grey facing outwards. Of course, you can't see this once you've started applying materials. But for 3D printing, it's very important. So one thing I want to show you how to do is how to look for these problems. So here's the cube, and just to demonstrate, if I delete the face off it, you can see inside, and I've got a slight bluey grey finish. Now I find it very difficult to see the difference between an outside and an inside face when I'm modelling. And so one thing you can do is go to the Styles palette, go onto the Edit tab and go to Face Settings. The first thing you see is front colour and back colour highlighted, and you'll see this white and grey. If I click on there, an easy thing to do is make that into a bright colour. So now I can really see what's inside and outside my model. Just to reiterate what I'm saying, if I was to present a model to be 3D printed, for instance, this one here, and I'm seeing pink faces, that's not going to print. I would end up in the 3D printing software that I have to use to process the work. I would see this as a hole, I would see these as holes, and I'd have a hole underneath. To 3D print, it needs to be solid, it needs to be what's called watertight. So there are some easy fixes. One thing I can do is go into the model, highlight the face that's shown as pink, right click on it and say reverse face. And that works quite well. I can do the same if I want. Holding my control button, I've selected this one. I'm going to select that one, and that one, and then go reverse faces. So you see, it doesn't take too much work to get this model ready for 3D printing. And reverse that face there. Now, I've just shown there, I'm going to undo that I've got a component here. This component and this component. The same object, I've componentized it and then copied the component. And that's a great way of working in SketchUp. Unfortunately, when it comes to 3D printing, the 3D printing software doesn't understand what a SketchUp component is. So if I make this change here, reverse face, that's great. This one's now fixed. But if I was to try and 3D print this, I would get this object, but this object would be missing. I see this quite often with windows. People make one window and then turn it into a component and copy it a bunch of times across the model. The way to get around this, you can do it one of two ways. You can do it, the better way would be to make this unique by right-clicking on it. Those two are now no longer the same object. I can make changes to this and I won't see changes here. So that's one way of doing it. The other way would be to just explode the components and turn it back into geometry. That's not quite so good a way of working because you want to try and keep them componentized. Okay, so we're talking about boxes and objects. Let me just jump to a PowerPoint. Okay, there's a few tips I want to show you on here. This is about making your models watertight. If you can see here, as I've pushed a window into this box, I've created a gap. I can see that grey in between. So if I'd have made that change, I would see that as bright pink as well. Again, that's not now a watertight object and it won't print. One thing to consider when you're printing is the scale that you're going to be printing at. And I'll talk about that again. But if you're scaling down a model and you've built a wall that's say 100 mil thick, and you're coming down at scale of 1 to 200, quick calculation says that that wall is going to print up at 0.5 mil thick on the 3D printer. And that's too thin for printers. So you have to think about scaling down and how wide or how big objects are once you get them down to scale to 3D print. Okay, another thing to look at is grouping and solid operators. And I'll jump back into SketchUp to show you this again. But using the solid tools, you can join components together. I'll quickly jump back into SketchUp and show you this. So let's make this back into a solid object again. There we go. Now I'm going to select all that, hit G on my keyboard to create a component, make sure that that's ticked on, replace selection with component. So that's now going to create a component for me. Okay, that's seen as one object now when I select it, and that's a great way of working, so I highly recommend that. I'm going to make another object, push that into 3 dimensions, call that a component as well, hitting G on the keyboard to create a component. Okay, so I've got 2 components. Now, for instance, say I wanted to print these 2, and I'm going to move that into that object there. Now, if I was to select that and turn that into a 3D printing file, it might work, but it might not work. I've got geometry inside of geometry. If I change my face style to X-ray, you can see that I've still got the box is going inside of the tube. So if I wanted to be ultra neat about doing this, I would use something like this, an outer shell tool. So this is under toolbars and it is under solid tools down there. So you can turn that on. And what this allows you to do is select one component and glue it to another component. There you go. That only works if they're watertight components, if there aren't any gaps in the geometry. So now let's remove the inside of there. And that helps the 3D printing software process and work with things. Okay, if you're doing the IT for Design module at the moment, I'm just going to change this face style away from X-ray. You'll probably recognize this 100mm by 100mm with a small building on the top of it. Now, one thing I do ask people when they're printing is, do you really need a base on it? I would recommend cutting this out of foam core or making it on the laser cutters and then gluing or placing down your 3D printed building on top of it. But that's just because we get a lot of jobs through, and that will save 2 hours off the build time. So I'm always trying to make savings where I can. However, I am aware that people like and do terrains. So here's a terrain that I've made. As you can see there, it's pink on the underside and it's white on the top side. I don't want any of this pink showing in my final model. So I've worked this through by drawing down, choosing one of the corners, drawing down, and then drawing down to meet up, and then making sure that that is closed off. One thing that helps with 3D printing is, so I pull this down a little way, make this base a little bit fatter. That was looking quite thin. The thinner the base, the more likely it is to warp. We do have some warping issues on the 3D printers. There's not a lot we can do about it at the moment, so I'm trying to find ways around this. One of the ways I've found around it is to reduce the amount of plastic that's actually sitting on the bed of the 3D printer. To do this, you can do something like an offset of, at the moment this isn't scaled down, but if it was scaled down, that would be about 1 millimeter. And then pushing back up in, just a little ways, but that takes the majority of the geometry off the bed. You're leaving a very small piece of plastic touching the bed there. It'll have support material underneath when it's printed, and I'll talk about support material in a minute. But that I'm finding is helping. So I can recommend doing that to your models. How I've put these together is I've made sure that all of these objects are watertight, as I mentioned before, and then I put the terrain together into this model here. Now this will 3D print nicely. I've still got these issues here, which I can reverse face. So keep checking that you're not seeing any of the bright color coming out in your model. Otherwise, you'll have holes in the model and it won't print properly. Okay, there are a few other things just to take into account when you're modeling, and then I think that'll be enough for you. One of them is this. I'm going to jump back to the PowerPoint and I'm going to talk about support material and overhangs. When you're 3D printing, if you're printing from the top, how a 3D printer works is molten plastic comes out of a nozzle from above and drops down like spaghetti. If it's going on to a base, then it's got something to land on as a molten plastic and build up. But as you can see here in this example, some objects that overhang, once it goes beyond 45 degrees away from what it's already printed on, so this is at 90 degrees, it needs support material underneath. So our printers will print a looser, easy to break out material underneath the material that we actually want to print. And if we haven't got support material turned on, this is what happens. You just end up with a failed model. So support material works in that way. Now, when you're modeling, I'm going to jump back to SketchUp again. Certain features on your model will print cleanly and certain features will have support material. As you can see here, if I was to print this from the top, pointing downwards, all of this material would be fine. I can't see inside my model. I've put windows that are closed. If these windows were open, then you'd see inside and you'd see all the support material that was used to help print the roof. But this feature here, for instance, underneath here, there is an overhang. That would have support material underneath it, which you'd need to get into with a scalpel or a set of pliers to pull out afterwards. And you might not always have the cleanest surface left behind. So that's to be taken into account when you're modeling. If you want more advice on that, come and talk to one of the technicians about it. But it can make you rethink how you want to print your model. I'll draw a very quick model on the ground, offset in here, pull up, etc. If I had an interior to this building that I wanted to show off, if there are some internal walls and features, then you're not going to see any of that in your 3D print because you're printing the outside of your building. So you see how easy, by the way, I do get this inside face. I can just reverse all of those faces to get that right there. So if I had an interior there and I wanted to show it off, one way of doing this would be, I'm going to group that up, would be to simply think about doing a model that was in two parts, where I might build a roof object like so. Now, I would then submit two files. I would have this one and that one, and I would submit them separately as two different STL files. I'm going to talk about STL files in a moment, but It's STL files that the printing technicians need, and we need to have them separate so we can orient them on the bed of the 3D printer to be efficient and to make sure we get the cleanest of prints possible. So that is one way of thinking about your model. Of course, this is still invalid because I've got pink faces showing. So a bit of neat and tidy care is needed. I need to extrude those up actually. So you get the idea. Those two there, reverse. Okay. Aha. Still getting problems underneath. Sorry, building too fast. I need to go slower to do this properly. There. Okay, that's now a legitimate model that could be submitted. So how would I go about submitting that? First thing I'd do, before anything with SketchUp, there's a particular issue, and that is with hiding objects. If you've got any hidden geometry, so for instance, say I took that and I hid it. Can't see it, that's fine, you might forget about it. But if I was to essentially delete everything off and just have that as what I'm going to submit, if I do that, there we go. Okay, so I'm thinking, great, I'm ready to do my work. If I then save that as a SketchUp file or exported it to a website, the hidden geometry will go too, because again, only SketchUp understands SketchUp hidden geometry. All other pieces of software will see the geometry is really there. So before you export, check that you haven't got any hidden geometry within the model, because this is what I would get. I'd get both that object and that object in the STL file, and I won't be able to do it, and I'd have to email you back. Okay, so checking for hidden objects, there and there. Okay, now I've got this. As I've said, there are lots of websites that you can upload SketchUp models to, which will convert them into STL files. There are quite a few, or you can get plugins if you're using your laptop and you have administrative rights. However, if you're at UWE, a quick and easy way to do this is to save as, and if I drop this back to a version 8, SketchUp version 8, and I'm going to just drop this onto my desktop so I can find it again. I'm going to actually put V8 in the title. And then I jump over to Rhino, which is installed on all the machines at UWE, and you can get a copy for your own laptops at home if you go through IT. But what it's very useful for is importing and go to a desktop. It's got to be an old version of SketchUp, so that's why I'm saving it back as SketchUp version 8. But when I open that, bring that in, and there it is. So it can bring in SketchUp models quite easily. All I need to do then is select what you want to export, File, Export Selected. That's a good one to use rather than Export with Origin. Export Selected just grabs the geometry that you need. And you're going to change the export type to a stereo lithography or STL file. That's the file format we need it as technicians in. Give it a name. I'm just going to call this test, but be descriptive. Put your name in the title as well. The more often we've got a copy of whose file this is and what it's for, so you might want to put your module title in there or something like that. just to give us a real clue as to who owns this model and who should get it back. So I'd hit that, hit save, and that will export an STL file. Okay, last thing to talk about though is scaling. Now, jump back over to SketchUp. Scaling, you'll be working at a 1:1 scale in SketchUp, hopefully. You should be working at a 1:1 scale. However, I'm just going to change that. There you go. However, our 3D printers are small and you need to submit this STL file at the correct size. We can't scale it down for you. You need to do that thinking yourself. So I've done a handy chart on my PowerPoint. These are the scale factors to come down in size from a 1:1 model to these different scales. We quite often see 1:200, so that's a scale factor of 0.005. So I'll use that as an example. So back in SketchUp, how do you do that? So to scale this down to 1:200, I'll select it, use the scale button, grab one of the corners, start moving, and then type 0.005. You can see in the bottom right hand corner of my screen, it says 0.005, then I hit enter. Now I've got a very small object. Do extents again. Okay. What's useful is if you put that near the origin, and just to check, I'm just going to jump back. Okay, here's the information here. We've got two types of 3D printers. We've got the Z18s, which are the big ones, and the Replicator Pluses, which are the smaller ones. These are the chamber sizes, 30 by 30 by 48, 28.5, 15.3, etc. Don't please go anywhere near this scale. It fails when it gets right to the edge. So try and stay at least a few centimeters in from there. But let's say we're working with 30 by 30. So handy tip is draw yourself a 300 by 300 millimeter square. There you go. So that's my printer bed. I know that this is going to fit on it. So it's that kind of thinking we need you to do first before submitting. Please don't leave that in the model because you'll end up with a big flat base. So, but that's the thinking you need to do. Now it's scaled down. However, you can do that in Rhino. Same thing. If I select this to scale this down, same operation really. Select the model, type scale. You've got a few scales in Rhino. You've got scale 1D, scale 2D. Just go for scale, which is the scale 3D. It asks for an origin point. I put that there, and it says what scale factor you want to use. So I'm going to go 0.005 again, same as I just did in SketchUp, and I get exactly the same. So now I can select that, go File, Export Selected, and choose the STL format, Stereolithography, STL, and export it like that. Okay, so I hope that helps. And enjoy using SketchUp for 3D printing. We're seeing some really good models coming through, and happy to help. So come and have a chat. My name's Patrick Thornhill, and there's another CAD technician called Justin Robbins, who I'm sure you all know, and we live in 2R23. So come and see us if you need some help. Okay, thanks a lot. Bye-bye.